Okay, guys, so let's go over this homework. First thing to know is that we're not doing the second half of it, and we're not even doing the bottom part of this, all right? So we're only doing the first three sections. So we're only doing the first section, which is classifying, the second section, which is comparing decimals and fractions, and the third section, decimal approximations. So I think we all understand the classifying part, right? Let's just go over a couple of these right here. What would you classify number one as? Rational. Because the decimal, any decimal or any fraction is a rational, even if it's negative. How about number two? Natural. Yes, it's whole, but natural is even more specific. How about number three? Rational again. I don't know, should I keep going or are we good with that first section? We're good. So to save some time, those are the answers for that first part of the homework. Oh yeah, well, if you need it, go ahead and pause it on the video, copy them down, check them out, and then moving on. The second part, they're pretty straightforward, pretty easy, especially when you're comparing numbers. Just think of the number line. 7's further to the right, so 7 is definitely greater than. Negative 10 is further to the left. Negative 7's further to the right, so negative 7's greater than, right? Again, number 3, we did this today where you get the same denominator. So the 1/2 and the 1/3, if you wanted to change it to be the same denominator, it'd be a good idea to change it to be a 6. And how would you do that? By multiplying by 3, and you multiply the top by 3. So you're really going to end up with 3 over 6, which is the same thing as 1/2. And then the 3 over here, you're going to also multiply it by 2 and multiply it by 2, and the 1/3 will become 2/6. And now you could actually, now that you have the 6 down here and the 6 over here, now you could compare the numerator 3 with the numerator 2, and you'll see that 3 is bigger than 2. So that's a greater than symbol between the two fractions. You guys get that? Yes, I get it. Okay, moving on. Is there anyone in particular you would like to see? You guys like to see number 4? Yes or no? All right, let's just multiply the 10 times 8. We're going to get 80. Let's multiply 8 times 10. We're going to get 80. Whoops, sorry. Not showing my work here, skipping around. Okay, so 10 times 8 is 80. That means that 1 times 8 is 8. 8 times 10 is 80. That means that 1 times 10 is 10. Maybe I should show my work. Put the 8 down here, 10 right there. So now we could compare the 8 up here with this 10 up here. I'm sorry, hold on one second. We could compare the 10 up here with the 8 up here because we have the same denominator, 80, and obviously 10 is greater than 8. So that would be right, this symbol. Wow, I am just messing up on this thing. Sorry. 10 is greater than 8. Anyway, let's jump to the decimal approximation of radicals. Now, in order to do this, the best thing to do is to write down a perfect square number list. And once you have this perfect square number list, it'll help you out, because if you think about the square root of 24, that's going to be a little bit less than the square root of 25. So the square root of 25 is 5. A little bit less than 5 would be what? 4.9. So you need that perfect square number list to be able to approximate these radicals. Okay, let's think about the next one, number 2, 145. Well, 145 is a little bit more than 144. So what's my answer going to be right here to the 12.1? Perfect, 12.1. And this is a decimal approximation. Okay. How about the ones we see right here? Number 5. Number 5 is the square root of 50. So that's going to be a little bit more than the square root of 49. So what's that decimal approximation going to be? 7.1. 7.1 decimal approximation. Because if the square root of 49 is 7 and the square root of 50 is a little bit more than the square root of 49, the answer has to be a little bit more than 7. Okay. Is there anyone in particular that you guys would like me to work out on this section? How about the square root of 17? What would you say that would be? Square root of 17. 4.1, that's right. How about the square root of 20? 20 is not super close to 25. It's not super close to 16. That's right, 4.5. How about the square root of 120 over here? Square root of 120? 10.9, guys, 10.9. We're out of time. Please get on Edmodo and check out what I post.